Can you hear me now? Is that better? Excellent. Good afternoon, everybody. Thank you for coming. My name is Stephen Coppins, and this is AJ Singh. And we are here to take you through some of the best practices around performance when implementing Dynamics 365 for finance and operations. Before we get started in this, I'd just like to say we have a lot of material that we would like to cover today, and because of that, would request that you save any of your questions, and I'm sure you will have lots of questions, until the end, so that we can ensure we get through the material that we have already prepared. So to begin with, there's going to be 4 key areas we'll discuss. Design principles, testing for performance, key patterns and anti-patterns, and the tools that are available to review performance. So to begin with, design principles. Designing for scalability. So what we're looking at here is to ensure that not only does the Dynamics 365 implementation that you prepare for your customers work with the current volume of transactions, but that it will be able to scale out as the volume of transactions and as the company grows. So some of the key principles we look for are designing for parallelism. So in here it's about leveraging multi-threading. So for example, if you have a large process which is going to do 50,000 selects on the database and insert them into a staging table for analysis later, if you're using one thread, then even though those individual transactions might be quite quick, it's still going to take one thread and it will process them all. Whereas if you enable that for multi-threading, then you can use multiple threads, 5, and reduce that by a factor of 5, 10 reduced by a factor of 10. And then as long as you can keep adding AOSs and threads, then as long as that's the bottleneck, you'll be able to continue scaling out your environment. We also recommend building lightweight components. So an example of this is the subledger posting process. Originally, it was designed in a synchronous manner, which meant that when you were posting your journals, that subledger had to be posted before that entire process was completed. That became a bottleneck. So what Microsoft did is they split it up into 2 separate components, and the subledger can now be posted either in batch or asynchronously, thus turning one long process into 2 separate individual processes, or lighter weight components. We also design for optimistic concurrency. So in that context, we're saying that a lot of transactions can occur at the same time without blocking each other and becoming a bottleneck. So this is reducing the number of locks in a particular table, which is reducing the blocking and allowing a larger volume of transactions to go through more quickly. Additionally, when looking at your entire solution, look at other forms of data storage. Relying solely on the transactional database for example, all of your reporting purposes, can put additional strain on the environment, which becomes a bottleneck. So there's BYOD, there's the entity store, data lakes. Look at the other technologies that are available to support other business requirements that your customers have. Additionally, design a sound data model. For those of you who recall the introduction of moving from 2009 to AX 2012, the database was normalized extensively. Now, denormalizing of that database can actually add performance improvements in scenarios where there are less writes and more reads. By denormalizing the database, you can reduce the amount of joins that are required between tables, so the selects are a lot more efficient. So look at the database model and ensure that, where possible, if required and if it is a bottleneck, look to normalize or denormalize the database slightly. And finally, in this particular scenario, design for shorter transactions. a number of times we are looking at customers who have performance issues, and there are very large transactions, and because of that, a particular table will be locked for a significant period of time. And then as soon as, if that's a very important table, like ledger trans, for example, that's going to be updated frequently, then that can cause blocking, which goes on to have greater impact on the performance of the environment. So always, whenever looking at it, short, concise transactions. Next, we want to think about the user experience. So, response time. The key areas here that we'd like to touch upon are using set-based operations. So again, while the AOS and the SQL database are very close to each other and transactions can occur between them in milliseconds, when you've got a large volume of transactions, 50, 100,000, then even those small numbers begin to add up. So if you're able to use set-based transactions and commit in one select statement a particular update, you're reducing that latency and offering a better user experience and better performance to the overall system. Additionally, consider online versus batch processing. So again, this is coming down to the user experience, the users moving around on their screen and they're trying to post a journal, for example. Now, there's the ability to post a journal from the UI and there's the ability to post a journal via batch. If they're doing it via UI and it's a large journal, they're limited by one thread. All those user interactions where they are submitting something directly to the AOS, it's limited by one thread, so posting that journal is going to take longer. Whereas if they submit it to batch, the batch can be figured to run across multiple threads and offer a lot better user experience. At the same time, because they've submitted it to batch, the user can now get on with their day-to-day tasks and move on and come back when they get the message that the batch has been posted. And simplifying the design. If a process is very complicated, it's going to take the user a longer period of time to work their way through it. And it's also likely that because of that complex design, the development and the work that goes into building the design, the database structure, the coding, all of these components will add to the complexity of the solution. And this in turn raises the risk of having a performance impact. And then refactoring a complex design and then turning it into a simpler design becomes again another more complex process. So if at all possible, keep the solution simple. Now, take into account database size. So what we're referring to here is wherever possible, if you are creating tables for your customers and you're wanting to keep a history of that table, if they don't need 7 years worth of transactions stored in there, create a cleanup job. Because the Azure SQL system is locked down and users can no longer go in there and do SQL maintenance themselves, you need to proactively create these database cleanup routines in order to ensure that you can reduce the volume of transactions, purge it, archive it, and maintain it yourselves in that case. One of the other areas we see causing problems is the use or misuse of caching. So caching enables the system to maintain the results of a particular query so that when that same query is executed again, the system doesn't need to go all the way back to the database to look for that same result. It can just get it from memory. Now, the lack of caching means that the system needs to do a lot of work. So being able to cache that data can, again, radically improve performance. Unfortunately, too much caching can also have a negative effect. So it needs to be measured and tested carefully, but look at caching as it can offer a great deal of performance improvements. Temp tables. So when, again, designing your environment, you have the ability to create temporary tables that can be used, for example, in memory. And again, these are very rapid. Reading from memory can be extremely fast and efficient, so therefore by using a temp table, the customer can get a better user performance experience. However, contrary to that, when that temporary table, if you look at the in-memory example, gets too large, that memory overflow starts to get into disk, and all of a sudden you get performance degradation. So use them diligently, understand and review the types of data that's going to be stored in those temporary tables and how it's being leveraged, and then optimize accordingly. And then consider asynchronous processing. So this is not a case of using the batch. This is a case of using the .NET Async framework, where you can take a particular user interaction, submit it off to the async framework, and it will go off and be processed on the AOS, and the user can continue. It doesn't lock down the UI. So this enables a greater deal of flexibility for the user to continue doing their work, without waiting for that response. And then I'd like to just quickly touch on OData. Only use it when necessary. It can cause performance issues, and AJ will get into more detail around the use and misuse of OData later on in the presentation. And the last concept around design is design for concurrency. This touches on the various components that we've spoke about. So concurrency is about having those multiple users using the system, multiple transactions going through the system, and increasing the volume of transactions in general. So these leverage the components, or some of the components that I've mentioned previously, such as building lightweight components, shorter transactions, and optimistic concurrency. So testing for performance. Why do you want to test for performance? Mainly to ensure the scalability of your solution. Is if, again, going back to the single-threaded scenario, it doesn't matter. If you're using one thread, it doesn't matter how many AOSs you add, how fast the database gets, it's not going to scale. It's just the more transactions you have, it's just going to take longer and longer and longer. So you need to test that your solution is scalable and will scale if you add more AOSs to it, if you add a bigger database, that performance will continue to scale accordingly. And so when it comes to what do you test, you need to be sure to look at the non-functional areas of the functional requirements. What is your throughput? What are your end-of-month processes? What are your peak volumes? And replicate those with multiple workloads, so integration, batch, UI, and understand that when you go live and during your month-end processes and year-end processes and your peak volume processes, the system will behave as your customers require, or as the customers require. And then where and when? Well, in a sandbox environment, non-production, performance environment, you need to do it, or we recommend you do it. Continue to do it. It's not something that you do once off and you're finished. It's an ongoing thing, because performance changes, customizations come into it, the environment evolves, the data evolves, so it's an ongoing process. So when we look at the various areas of a solution that can impact performance, there are 4 particular pillars that Microsoft is committed to building this solution, which is the servers, the database, Azure infrastructure, and the standard solution. And that leaves all the other components for customers, ISVs, partners, to ensure that they are working optimally and scalable. So integration, customizations, ISV, the data, all of these areas are under the customers and partners' power to control or to leverage or use accordingly, and they need to take that under control. So when we look at the performance and the key areas of responsibility, the customer is responsible for ensuring that they clearly describe what their business processes are and understand the transactions and the volume of transactions that are going to go through their environment so that they can explain and articulate that to the partner who needs to capture that information and the non-functional requirements in order to be able to build the solution and then educate the partner, the customer, and how all of that's going to fit together and how they're going to performance test for it and then potentially look at changing business processes in order to ensure that they can meet their performance requirements. And then Microsoft, while they leverage, control the production environment, and will take the information, the telemetry and the sizing information to provision the production environment. And when it comes to areas that are under Microsoft's control, whether it's creating a hotfix or adding an index, we'll take care of that in the back end in order to, and where it's not necessarily Microsoft's ownership of that area, will help, troubleshoot in a advisory support. And so, as I mentioned, it's an iterative process. Performance isn't something you just tackle once and then you walk away from. You try and identify the key bottlenecks at that particular time. You address them, you fix them, you put that fix, you test that fix, you find the next bottleneck, and then you fix that, and then you fix the next bottleneck, and then you test again, until you've been able to provide until the performance metrics have been met for the customer. And on that note, I'm going to hand over to AJ so he can talk about key patterns and anti-patterns.
Thanks, Steve. Hi guys, can you hear me okay? Yeah, key patterns and anti-patterns. So as part of Fast Track team, we proactively and reactively monitor customer environment, do performance reviews, and what we are seeing is that certain best practices which has been implemented by the project team, which is good for others to know and follow that. Some of the things that either we are missing or are being ignored as the part of the project team. So the list is big, but out of that, some of the key things that I wanted to touch upon, which we need to, it's kind of, you can say it's a do, a don't, when we do the implementation. So I'm not going to read out the list. We have the detail in the next slide that I'm going to talk about. The very first thing, data management. So always we have been seeing is the data management framework being used for heavy export and import, which is all good. What we are seeing certain being ignored is some of the key items in the data management framework, which helps you to do the bulk data export import in more efficient way. So the one thing is that use of the delta load. Wherever is possible, use delta load instead of doing full sync every time. So if you do the full sync every time, it's an extra overhead to the database. So wherever it's possible, use delta load, do full sync once, and then the incremental load going forward. The next is enable set-based processing. Steve talked about the database level set-based processing. The same applies here in the DMF as well. Whichever the entity that is possible, enable set-based processing. If you're building an entity, if you build the entity in a way that the set-based processing is allowed, use as much as you can to speed up the data load. And I'll touch base on with an example of the set-based processing, what we are seeing in the code pattern later. Then maximize performance by parallelism. This is one key that we have been seeing, that we get a complaint that my customer load is not what it's supposed to be. It's taking a lot of time to load the data. And what we see is that there is no memory constraint, there is no CPU constraint, there is no DTU that we are seeing on the database side. Where is that all time being taken? What we are seeing is that the customer and the partner is not utilizing the parallelism framework that DMF is providing. So I'll touch base on that one a little bit with the screenshots. I can't go with the demo because of the time constraint. Disable unnecessary validation and the configuration key. That's again key for the data load. If you have unnecessary validation, you are adding overhead while loading the data. Disable the configuration keys, the columns, the tables that you are not using, the feature that you are not using. Disable those configuration keys so that while data load, you are not touching those tables. Set up number sequence with pre-allocation. I'll touch base on this a little bit later in the detail, but the number sequence we recommend to use non-continuous for the heavy data load numbers and use pre-allocation. Cleanup, last but not the least, cleanup of staging tables in cases of recurring integration. We have been seeing that is being ignored, and the table keeps growing, and you start having some performance issues. So for the key thing that I wanted to talk about here is on the change tracking, which helps you to do the incremental data load and the set-based processing. Go to the data management workspace, entities, and you can see against the entities the change tracking there, and the set-based processing. So this key thing to call out here is that whenever you build an entity, make sure that if entity is built in the way that it can support set-based, try to use set-based. The next thing in the DMF is often been ignored is the parallelism that we spoke about. So in the data management framework, if you go to the framework parameters and in the entity settings, you have configure entity execution parameter, and where you can define the row count, import row count, and the number of threads. So you can see in the example we have 1004. So if you have 4 threads available at a time, you can import 4000 record parallelly. That's what often been ignored or maybe overlooked. Misuse of OData. This is while we do the proactive monitoring, we have been seeing high SQL utilization because of the OData query that is coming out, and it's sometimes it's being done intentional, sometimes it's been unintentionally. We are using OData connector for the Power BI, and that's causing an extra overhead to the AOS and the SQL Server. OData is not designed for heavy data load kind of integrations. It's designed for more of the real-time situation where you want to just fetch the information, and it's an synchronous based transactions, which means that the caller is going to wait for the callee to return, and in that case you might see some timeouts as well. So I talk about the prefer again. Going back to the earlier slide, the preferred method for the data load is DMF, where we are spending more time and resources to optimize the framework. You might see that different entities versions are coming in, and we are enhancing the framework. OData in our testing that we have seen is the load that is handling maximum is around 1000 to 5000 lines per hour, in contrast to the DMF, which is 200K and over. OData, the integration based on the OData is row by row, so it's always going to be slow. You can't use set-based that you can do with the DMF. You can't do sequencing with the OData. You can't define the entity that import first and the later. That can be done in the DMF. There's no batching that you can do in the OData, and so here what we wanted to kind of emphasize is that always use DMF for the data load, other than situation where you need a real-time information, you can go with the OData. The other places that we are seeing the OData being misused is to build a Power BI report. So often we have been seeing that through AOS and back to the transaction, through AOS and back to the transaction, through AOS and back to the transaction DB, which is causing an extra load to the AOS and the database. We recommend use entity store to build a Power BI, or get BYOD and do all the wanted to do with that, building a Power BI report on top of it. Batch framework. The batch framework, if you look at the framework we have done a lot of change in enhancement in the batch framework in the backend. But for UI, it's kind of same like what we had in the 2012. So what we recommend for the batch framework optimization or the batch optimization is that create a time schedule for your heavy batch jobs and assign those heavy batch jobs to individual batch groups and assign those batch groups to the AOSs so that the heavy batches are not conflicting each other and creating a resource constraint on AOS. And we also have a throttling, so we are not doing a throttling so that the batch gets delayed. Setup, I won't go to that one. It's the same what we had in the 2012 days. Go to system administration setup, create batch groups and assign batch group to the batch AOS. Other things too I wanted to touch base here is that which we introduced in Q21 called active periods for the batch jobs. Earlier days, when you schedule a batch job to run every alternate hour, but you want that job to run only in nights, not in the daytime. That wasn't possible before. With active periods, what you can do is that you can define active periods that you can show no bus, the active period that I have defined, is that, okay, I wanted to run a divine active period from 8 p.m. until 6 a.m. in the morning. I defined the active periods, assigned to the batch job. The batch job is, the recurrence pattern of the batch job is designed to run every alternate hours, but it's not going to run in the daytime. It's going to run only after 8 p.m. until 6 a.m. If the batch job never finishes at 6, what is going to happen? The batch system is not going to stop batch to finish. The batch is going to finish if the time is going to finish, but it's not going to start before after 6 a.m. So that was introduced in Q21. Number of threads. Given the fact that you don't have clarity about the number of CPU cores that you are going to have the production, what we recommend is the number of threads default value is 4. We recommend that do a mixed load testing on your sandbox environment with interactive user, batch jobs, and monitor the load on AOS. And based on that, we recommend to go with the number of threads. We are not recommending a number, but mostly that we have been seeing is 8 until maximum 12. Multi-threading the batch processes. So there is a very nice blog article posted in AX 2012 days by the performance team, which the API is the same what we have in D365. We recommend that reading those blogs and implementing, if there's any heavy batch job that you are designing, make sure that batch is following those patterns, whichever fits your requirement, and designed to run in the parallel. Index. So the thumb rule for OLTP database, make sure that all the table that we are designing has the cluster index defined. And whenever you define a table and you have a query which is taking, so often like if you have a table, example, in our example, cust table, I'm selecting account number and the cust group is 40. I don't have an index on the table. What it's doing right now, it's doing a scan of the entire table, then filtering out the record that I wanted to. The record table scan always been expensive in terms of the number of time it takes the CPU, the logical reads, writes, and the SQL processing time. What we recommend is that always consider selectivity when you write a select a statement, and define a proper index for all the table that you are defining and the query that you have been writing. One more thing, just go back to my previous slides, which I'm going to touch base later, is that certain times you see that you have an index defined, but your query is not performing or not picking up that index that you have defined. So the last resort is to create a plan guide. I'll talk about that, the tools that we have available to create plan guides in the production environment. Number sequence. Always we have been recommending use continuous only if it's a legal requirement, if it's a compliance requirement to have the continuous. Because if you have continuous number sequence, we are holding that number with the transaction ID into a table called number sequence TTS, which often you might see that it's being a bottleneck in your environment. You see a blocking on those tables. So we recommend that often only use continuous if it's a legal or compliance requirement. Use non-continuous. However, with non-continuous, still we are making one by one database call for fetching the numbers. We recommend use pre-allocation. I hope you are all aware about the number sequence pre-allocation. You just define the pre-allocation 10, you go and create a sales order, it's going to fetch 10 numbers and store in memory. Until the 10 numbers you use, it's not making any database call. So it minimizes the database calls and improves the performance. The advice on the number of the pre-allocation, again, it's based on your the number that you are consuming. There is no the number that we are giving, but the advice that we have is that if you have 75K number being used in a day, go with 100 or maybe 100 as a pre-allocation, because if you go higher number as a pre-allocation, you might end up exhausting all the numbers very soon. Set-based operation. So this is one example that we captured for the set-based operation. So you can see in the red one is that we're trying to update a customer table with value A and while select 1000 times, and I'm trying to update that. The same thing can be done with the set-based operation, that I can update all the record in one go. So though your AOS and the SQL server is lying in Azure, but it's still there's a database call that you are making for each row and update it back to the database. To minimize that and improve the performance, we recommend to use set-based operation wherever it's possible. There are certain caveats that you need to note. If you have the table insert, update, delete method being overwritten, set-based operation does not work in that case. So you need to make sure that you are using skip methods before you use the set-based operation. If you have Q8 and before, if you have the database log enabled on the table, the set-based operation was not working. However, in Q8 onwards, the database logging is now a trigger based. So even if you have database log enabled, the set-based operation still works. If you have alert enabled on the table, the set-based operation does not work in that case as well. We capture traces of the same code base before and after, and you can see maybe the time that you see is not huge because it's just one method call that we were monitoring, but the number of execution count that you can see. Cache lookup. So Stephen talked about aggressive caching. So one thing that I wanted to call out here is that in D365 FNO, the batch exe and AOS IIS is not sharing cache. So whenever you have a table being cached, entire table cache, hope you all know about the table cache property. So we have a different table cache property called entire table cache, not in TTS, found and empty. So for example, you have a table which is set to entire table cache. So we cache the entire record on the AOS memory and the batch memory, and that table is being frequently updated. So whenever you update the table, the AOS is going to send a notification to all AOS to flush your cache and update, and that adds an overhead to the database. So always aggressive caching is not good, but again at the same time, if you do the caching proper way, it always helps to minimize the database call and improve the performance. The one thing to note here is that if you decide a table and if you don't have any unique index defined on the table, the caching does not work. AX29, 2012, D365, the caching mechanism in D365 and 2012 is kind of same. 29 was different, that you need to have a primary key defined. If it's not primary key, then it doesn't work. Then the join was not supported in 29 days. In 2012 and D365, even we support cache in the join. Example of the data caching, cust table, by default, it's already been enabled for the cache. We wrote one line to disable the cache, and then just did 1000 times select for the same value, for same customer account. And you can see the number of calls. The previous where I disabled the cache, the number of calls was made was 6,500, and the number of calls made, and the second where I had the cache enabled just one time. So always make sure that you are using the right set of cache, whether it's all the different types that I spoke about. There is a best practice that we have posted on the docs. It's about the different table groups and the caching that you should be using. Use of generic method. So it's been a best practice discussion in the community that use a generic method instead of writing your own. So like use find, use exist. But often we have been seeing that use find, just one example, use find is being misused here. If you see that, what I'm trying to fetch is that I wanted to fetch the customer record, customer agency location code, bank account, cash discount, and default, and I wanted to fetch all this column. So instead of using one find, find cust table, store in a variable and get all the columns, what is being done here is that I used 4 times find, which means that I'm making 4 database calls. That could have been avoided by just making one call and store in a variable and use it. One more thing that we should be considering while using the generic method is that I'm using only 4 columns here. But what I'm doing is that the find is selecting all the columns. So if you go to the SQL and look at the query plan, though I have an index defined, it's doing a key lookup because it's select a star from the table. It's selecting all the columns, and there is no coverage index for all the columns that I'm selecting. That also impacts the performance. So what we recommend is that in this kind of situation, instead of using find, select 4 columns from the cust table based on the cust account. We captured a trace, and we can see the difference of the time taken and the number of calls. Cleanup jobs. That is the one thing that we have been seeing is that often being the cleanup job that we saved with the base D365 being ignored. So make sure that you do a periodic cleanup, your batch history, log only when it's needed. Do you really need to log all the batch history? Make sure that you are cleaning up your all notifications, cleaning your DMF staging that we spoke about, and then cleaning up the journals. Cleaning up the inventory journals, you can clean the GL journals which are not posted. Again, posted GL journals you can't clean up, but inventory journal, even though they are posted, you can do the cleanup. One thing on the inventory journal cleanup is that so often we have seen that inventory journal parameters, you have a checkbox called delete journal lines after posting. We are not encouraging to use it. Use cleanup routine to clean instead of deleting those journal lines at the time of posting, because it creates an extra overhead, and often we are seeing blocking on ledger journal invent journal trans table. So no, I want to encourage to use that flag, use this job to clean up. And we have posted a community blog to talk about all the cleanup routines that we have, but I wanted to touch with some of the key from the warehouse management, work creation history. It's been growing very fast in the customer environment. There is a way that you can disable it, or there is a cleanup routine that you can clean up as well. So like I said before, log only if you need it, and if you are logging it, make sure that you are doing a periodic cleanup. Containerization history, web batch cleanup, and the mobile devices activity log cleanup. Make sure that you are running all these cleanup jobs periodically in your environment. These are kind of related with the warehousing. On-hand calculation jobs that I wanted to highlight here is that inventory dimension cleanup, delete your unused dimension, because when we import dimensions or create dimension, we use find or create. So you might end up creating a lot of dimensions which will not being referenced. Clean up those dimensions. Warehouse management on-hand into cleanup. So that is very key for the warehousing on-hand query performance. Aggregate measurement. So those who are on PU23 and less, what we have been seeing from our telemetry monitoring, or maybe I will say that earlier days, maybe a few months before, in maybe 30% of the total escalation that we were getting in the performance was all caused by entity store and aggregate measurement refresh batch job. What we have been seeing is that the multiple instance of the batch job that is running to refresh the entity, and it's not just taking a lot of CPU resources, it never finishes up. So you are not getting even updated refreshed entity store. So what we recommend here is that those who are on PU23 and before is that if you have a batch job that is doing an entity refresh for all, disable that batch job and categorize into 3. Very first one is that do you really need all entity to be refreshed? Do you need all aggregate measurement? Are you going to use all that in your embedded Power BI? Second is that do you really need to be refreshed every alternate hour? So filter out all the entities that you need every alternate hour or maybe twice or thrice in a day. The third category is that the reports that you use once in a week or once in a month. Then just let's have 2 batch jobs, one that refreshes very frequently for the aggregate measurement where the report you are using frequently, and one which is we are not using it. And with that change, at least what we have seen is that the customer DTU from 100% came down to 30%. So that is very key for the customer, those who are in PU23 on. So we have posted a blog as well. For those who are on PU23 and onwards, it's a different UI screen that you have. So now you can schedule entity-wise a job to a refresh job. Job in the backend is only 2, but you can schedule which entity you wanted to refresh and what time of the day. So you can schedule an entity to run in the evening and schedule an entity to run to be refreshed into in the daytime. Stay current. I'm not going to spend a lot of time here because with run 1 or the green ERP, you have to be in the current. But always, whenever you see some issues, my recommendation is to go and find maybe there is already a fix out there before calling Microsoft. So always make sure that you check for the fixes there before calling to Microsoft. Execute index maintenance. So with SQL Azure, where we have very fast storage technology that is coming out, we still see a benefit of doing an index rebuild index against the databases. What issue that we have right now is that we can do automatic rebuild index against customer environment. We are doing updated stats using automated job based on what we look at is the number of records being inserted, updated in the table. We picked up those tables. We do updated stats at least I think thrice a day, and even we have a smart monitoring which monitors, and if it feels that okay the plan is being deviated, I need to update the stats, we do that. For the rebuild index, we need a kind of a quiet system, which we can't predict from the customer environment when is the system is quiet and when we can do the rebuild index. So with PU22, we introduce a system batch job which does the rebuild index. And in LCS, in the SQL Insights, you have on-demand rebuild index that you can do. The issue that I am seeing, or maybe the limitation that we have with the SQL LCS rebuild index is that by table. So you need to know the table and then the index. You can do one by one. You can't do all the index rebuild. You can't schedule from LCS. However, using that system batch job, this is when you do from the LCS. Just go and select the table, select the index that you wanted to do. Rebuild index, provide the reason, because we are maintaining history of all the statement that you are executing against the system. Whoever runs it, it's our team, support team or your team. Whoever runs any query from the LCS, there is an environment history maintained. So that's why we are asking the region for who did that rebuild index. System batch job. So if you go right now, so there is no menu item for this batch job. So when we say system batch job, if you go to the batch job form, you can see there is a batch job called database index rebuild, which is scheduled to run at 3 a.m. admin user local time zone. So if admin user local time is in Eastern, it's scheduled to run at 3 a.m. and it's doing a rebuild index job, and then we introduced an inquiry screen within D365 FNO where you can go and verify the index fragmentation before the batch job finished and the after. In certain cases, you see the index fragmentation before and after is same. And the reason is that we have a parameter form that is being introduced in the system parameters called system job parameter. I'll show that in the next screen. So what we have is that we have certain threshold defined. So basically, if you look at what we have is the maximum execution time. The default value is 120 minutes. So the batch job is going to do rebuild index only for 122 minutes. Number of indexes to pick up. So it's not picking number of tables, it's picking number of indexes based on the criteria of the table having 1000 on web records, the fragmentation level is more than 75%, it will pick up top 500 and do the rebuild index. Then we have DTU threshold. If your SQL DTU is more than 50% at the time the batch kicked in, the batch will wait for a certain period to see there is a relief on the SQL DTU. If no, batch won't do anything because the batch is designed not to interrupt your business process. My recommendation is that what we recommend is that on the weekends, whenever you see that your system has less activities, not a heavy batch job running, less users are there, you can play with the parameter. Maybe you can change that parameter to 4 hours in the weekend. You can change the count of index to be fragmented to 1500, and you can change the SQL DTU threshold to 75% to get more indexes being fragmented. The other thing is that when we run this job, when the job runs, it looks for the table that is going to, let's example, I got cust table, and at the same time, if you are creating a cust table or some process is trying to create a record in the cust table, it will skip the table. So you will see that, okay, the stats being captured, the fragmentation level of the table, cust table index is this, and after that, it's the same because it was not, the batch job didn't interrupt your process to acquire a lock and do the index fragment. We added in PU26 a flag called offline mode. So the offline mode is that to rebuild index, it will acquire the lock. Whatever you are doing, it will acquire the lock, it will wait, acquire the lock, and do the rebuild index. So the offline mode is recently introduced in PU26. So it's a kind of same that you go and reach out to the support team, hey, you wanted to do a rebuild index. They'll say, okay, I wanted downtime. It's the same thing that we have enabled customer to do it themselves. Plan guides. We are not encouraging to use plan guide as a first mitigation step. Always try to find out, can you optimize your query by adding or changing that index? Can you increase selectivity on your query so that the query picks up the right index? Can you add an index? Can you rebuild index, update statics and fix your query? If that all does not help, then the next resort that is to use the plan guides. Hope you all know the plan guide. You can force a plan, an XML to SQL to pick that plan, pick that index all the time. In LCS, in SQL Insights, you have an option that you can go and create the plan guide. The thing here is that you need to know the better plan. So basically, when you go to the LCS monitoring and you see that, okay, one query, you have the query ID there, you have the user who is running the query, you have the time taken by that query, you have all the information there. So picked up the query ID, go to LCS queries, find out all the plans against that query in past 24 hour, maybe 30 hour. And then from there you need to decide which is the best plan that I'm going to use. Pick the plan ID from there, come to LCS action and provide the plan ID there. You can see the number that we are providing. So what it will do is that in the backend it will pick that the plan from the query store, plan XML and attach with your query. Okay. The risk with the plan guide is that if you make any data model change, if you add a new column, if you remove an existing column, the plan guide is not going to work. If you have, while copy pasting the query, if you add an extra white space, in that case as well, the plan guide is not going to work. So we have to be very careful when we add the plan guide. Next one is okay, plan guide. There's another way to use the plan guide is that providing table hint. So one is to attach existing plan. The other is to force SQL Optimizer to use my index all the time, which we can do it by, again, the same procedure. It's a different option to use index hint or force SQL, whatever that table hint that you want to provide. You can provide that and it will build the plan guide based on that hint provided. Okay, that's all on that, the key patterns and anti-pattern that we have been seeing. And I'll pass it on to Steven now for a case study for one customer example where we improved by making some configuration changes.
Thanks, AJ. So we just wanted to bring to attention this particular case study because it highlights that problems with performance don't always require scaling out, scaling up, or creating indexes or tweaking the code to optimize the code, because it was already optimized, it just wasn't being leveraged. So in this particular scenario, a customer came to us and they needed to import and post journal lines with over 200,000, well, a journal with over 200,000 lines. And what they found was that it was taking somewhere around 20 hours to do that process, and that wasn't satisfactory for their business requirements. They needed it to be reduced significantly. So they came to us and said, help. And we started looking at the way that they were doing these things. Now, this isn't all of the issues that we addressed. However, it's some of the main ones. So again, they were only posting using one AOS. So they had multiple AOSs available, but they'd only configured one to be enabled for the posting process. So again, not leveraging the multi-threading capabilities of the posting process. Additionally, sometimes the users were just posting it from the UI. And again, when you're posting a journal from the UI, you're down to one thread. And again, that becomes another limiting factor. So we said, look, under all circumstances, post it via batch. And immediately they saw performance improvements. When it came to creating the journal and the way that the journal was imported and then the way the journal was posted, they were using continuous number sequences. And that was becoming a bottleneck, just the generation and maintenance of the number sequences. So we requested that they change the temporary vouchers to non-continuous number sequences, and wherever possible, change to non-continuous number sequences with pre-allocation. And we asked them to change, again, the batch transfer rule that they were using was synchronous. They changed that to batch schedule. And additionally, they, because of, posting one journal with 200,000 lines can take a while, there's the ability to actually specify how many lines should be in a journal or max number of lines, and then finance and operations will actually split it accordingly and via some other rules. So they set the lines limit. And for those of you who are aware, there's a one voucher concept within finance and operations. Some of that is not very efficient from a performance perspective, and so Microsoft is deprecating that feature slowly over time as they replace it with other functionality, other features to replace the functionality. They were using one voucher, but they didn't require that functionality, so we asked them to stop using it. And after making these changes, they got the time down from approximately 20 hours to somewhere in the vicinity of 4 hours, which met their requirements for posting this end-of-month journal. So just to end off, quickly just to highlight a few of the tools that can be used for performance troubleshooting. So depending on which environment you're looking at, there are various tools available for yourselves to use. And I'll just highlight some of these quickly. LCS monitoring, again, good for the tier 2+ environments in your production environment. Microsoft is adding a lot more features to LCS, and they are making it faster and more efficient to troubleshoot. So in LCS, you can see a significant amount of information and download your logs over the past 30 days for slow queries and crashes and all these various telemetry, which will enable you to troubleshoot performance issues. Trace Parser. So on all of your environments, you're able to capture a trace, and then in your dev boxes, analyze that particular trace. And that captures not only SQL, but also the X++ that's run. By default, when you're running in production, the maximum size of that trace is only about 1 gigabyte. So we recommend you identify the particular scenario, replicate it in a non-production environment, you reduce all the other activity as much as possible so that you are only targeting that particular process so that you can capture as much of that as possible in that 1 gigabyte. If indeed that's not enough, there are processes to capture using Windows Performance Monitoring a larger trace by going onto the AOS server, and there's a blog article about how you can do that sort of activity, and that's all in a sandbox environments or non-production environments. And then there is the performance timer, which you can enable on all your environments by appending at debug equals develop, and that will show you how long the particular form took to open with some information about what was occurring on the server. Additionally, F12 and browsing tools on your various browsers can show you a lot of telemetry regarding networking, information, memory, that can help troubleshoot the front end of the particular issue. And then the query store, which is a feature of the database, which just captures a huge amount of telemetry regarding all of the executions of all of the queries that are being run across the database. And once you get access to that query store, you're able to run a huge number of queries across it to extract heaps of information about what queries are doing, what indexes may be required, what indexes are missing, runtime stats, which query plans are being executed. It has all of that information available to be analyzed and reviewed. And lastly, the Optimization Advisor, which is a nice way for ISVs and partners and Microsoft to make rules about activities such as cleanup routines that can help remind the customer that there is an activity that they can do in order to optimize their system. So these are customizable and can be added to by partners, customers, and ISVs. And with that, we're almost out of time, but a quick sort of Q&A if there's any questions. Yes? Sorry? Okay, yes.
Yeah. Yes, so let me take that question. So the bad job that you see to compress the database, it's only applicable for the users, those who are upgrading from X2012 to D365. So customers, those who are going live with the D365, we have a code in the kernel to compress all the tables. So that bad job has no impact. Though it's running, it's not taking any resources.